Look at your hand. It seems finished, quiet, obedient, skin over bone, bone over atoms. Matter resting in the oldest disguise it has ever worn, stability. A stone feels stable, a planet feels stable, a human body feels stable. But this is the first lie, because inside every atom heavier than hydrogen, there is a crowd of positive charges packed into a space so small it should never endure. They should drive each other apart, they should burst the nucleus open. And yet they do not, which means something hidden is intervening. Something small, something ruthless. And we know it is real because NASA's Fermi telescope found its fingerprint not in peace, but in the wreckage of dead stars, in gamma rays rising from supernova remnants where neutral pions were born and died almost instantly. The thing that helps matter stay calm leaves evidence in cosmic violence, so the world around you is not resting. It is being restrained. The beautiful image breaks the moment you go inside the nucleus. Protons are not gentle neighbors. They repel, relentlessly. CERN describes the strong force as the force that holds the atomic nucleus together against the repulsion of protons, and it does so only across a brutally short range. Not across a room, not across a planet, across almost nothing. Across a distance so tiny that stability begins to look less like a law and more like a narrow escape. This means matter is not a peaceful object. It is a sealed conflict. Every nucleus is a locked chamber, a pressure vault, a place where disaster is permanently delayed. From the outside, an atom looks complete, almost innocent. From the inside, it is a standoff between things that want to separate and something stronger that refuses to let them go. That is the real architecture of the world, not stillness, suppression. And for a long time, nobody knew what the jailer was. Scientists could see the crime. They could see the evidence. Protons should have fled from each other. Instead, they stayed, bound, silent, forced into coexistence. Somewhere in that darkness, a culprit was at work. Then came a man who treated the nucleus like a message left at a crime scene. In 1934, Hideki Yukawa looked at the range of the nuclear force and did something almost unnerving in its confidence. He reasoned that if the force reached only a tiny distance, the carrier responsible for it could not be massless. It had to have weight. He predicted a new particle with a mass about 200 times that of the electron. He did not dig it out of a crater. He did not catch it with a telescope. He deduced it from the length of the wound. Years later, experiment would vindicate him. That alone should trouble you. A particle first appeared as an absence, as a missing answer, as a thing logic found before the universe surrendered it. And even after it was found, it did not become simple. CERN notes that pions, particles made of a quark and an antiquark, mediate the interaction inside nuclei, and their own behavior remained difficult enough to puzzle physicists for decades. The messenger that keeps the nucleus from flying apart is itself not clean, not obvious, not serene. It belongs to the same family of hidden things that solve a mystery only by opening a deeper one. This is where the story becomes stranger than the popular version. People say the strong force, as if that phrase explains everything, as if naming the darkness is the same as seeing inside it. But the nucleus is not held together by a vague slogan. It is held together through a residual interaction carried by pions moving between protons and neutrons like forbidden couriers, fleeting messengers crossing a gap that should end in separation. CERN describes pions as flitting between protons and neutrons in the nucleus, mediating the interaction that binds matter together. Not a chain, a haunting, and it gets worse. CERN also reminds us that the bulk of ordinary mass does not come from some comforting pile of solid ingredients. Much of it comes from strong interaction binding energy. In other words, matter is not merely assembled from pieces. It is held into heaviness by violence, by interaction, by confinement, by a hidden budget of force that never stopped spending itself. So your hand is heavier than it looks for a reason darker than intuition permits. It is made in large part from captivity. And if you want to keep following these buried forces with me, the ones that hide beneath planets, stars, and your own skin, stay close. Subscribe, not for updates, for descent. Because the deeper we go, the less ordinary reality becomes. Now the scale shifts. because a particle this small does not stay trapped in textbooks. It rises into astronomy like a confession. In massive stars, fusion climbs element by element until it reaches iron. And there, according to NASA, the bargain fails. Energy-generating fusion stops. The core grows too heavy. It can no longer support itself. Gravity takes the throat of the star in its hand, and the core collapses. The outer layers fall inward. Then comes the rebound. Then comes the explosion. A core collapse supernova. This is not merely stellar death. It is nuclear law written at planetary scale. The same rules that permit matter to exist also decide when a star has gone too far. The same invisible order that binds a nucleus can become part of the chain that ends a sun. Stability is not mercy, it is an arrangement. And arrangements expire. Fermi saw what came after. In the remnants called IC443 and W44, NASA's telescope detected the unmistakable signature of neutral pion decay in gamma rays. That means protons had been accelerated to near light speed inside the debris of exploded stars, smashed into normal matter, created neutral pions, and those pions died into gamma rays almost immediately. The messenger of nuclear binding also appears in the forensic ash of catastrophe. So the particle that helps hold the nucleus together is not a saint of order. It walks through fire, it leaves tracks in ruins. And once you understand that, certain worlds begin to look different. Not brighter, more cursed. Take Enceladus. From a distance, it wears innocence well. White ice, clean light, a small moon circling Saturn like a frozen relic. But Cassini revealed something underneath that surface, a global salty ocean, jets of water vapor and ice, simple organic chemistry, and evidence pointing toward hydrothermal activity where liquid water meets rock at high temperature. In another setting, those details would sound almost tender. Ocean, heat, chemistry, the ingredients of familiarity. But Enceladus is not gentle. It hides its sea under armor. It vents that hidden ocean into vacuum. It keeps possible habitability under ice, in darkness, beneath a crust that seals hope inside a lethal shell. This is an Earth-like place only in the most unnerving sense. It resembles the deep ocean floor and yet exists in a realm, built for silence, radiation, and cold. Hope here wears a death mask. And Enceladus is not alone. NASA's case for Europa is not romantic. It is clinical. Life, as we know it, needs energy, the right chemistry, and temperatures that permit liquid water. Europa may have that combination beneath its frozen exterior. An ocean under ice, chemistry below a shield, another world that does not advertise its promise on the surface, but buries it under resistance. Now step back and see the full cruelty of it. Without bound nuclei, there is no oxygen to dissolve in alien seas, no carbon chemistry, no water molecules worth chasing across the dark, no ocean worlds, no breath, no blood, no dream that life might wait beneath the ice of a distant moon. The hunt for life begins far below biology. It begins inside the nucleus, and our machines have been listening to that secret for years. Fermi saw the gamma-ray fingerprints of pion decay in supernova remnants. A MS-02, mounted on the International Space Station, continues collecting and analyzing billions of cosmic ray events, watching charged particles from the galaxy as they arrive like coded fragments of a larger story. Even now, overhead, an instrument circles Earth and keeps count of the messengers that cross the dark. And then there was Cassini. Cassini looked at Enceladus and Titan long enough to transform them from distant moons into possible habitats, perhaps even prebiotic sanctuaries. Then NASA ended the mission by driving the spacecraft into Saturn itself, not from failure, from caution, because if left uncontrolled, Cassini might one day have struck one of those moons and contaminated the very worlds it had taught us to treat as sacred unknowns. So it was sacrificed, burned in Saturn's atmosphere to protect the places where life might be waiting. That is how seriously this mystery is taken. A machine crossed the solar system, found worlds that might carry the chemistry of life, and then died so our touch would not arrive before our understanding. All of this leads back to the smallest figure in the story. Not the star, not the moon, not the telescope, the nearly forgotten courier inside the nucleus. The pion does not live long. It does not dominate popular imagination. It does not enjoy the fame of black holes or the glamour of exoplanets. It is brief, obscure, almost embarrassed by its own existence. And yet it helps keep protons and neutrons bound, helps make nuclei possible, helps build the elements that stars forge and worlds inherit. Remove that hidden labor and the universe becomes simpler in the worst way. No rich chemistry, no oceans under ice, no iron cores waiting to collapse, no path from stars to blood, no living world daring to wonder what holds it together. So the warning is not that the universe is hostile, it is that the universe is conditional. Everything you trust, stone, bone, atmosphere, ocean, moonlight, memory, stands on hidden negotiations. The nucleus does not hold because reality is kind. It holds because invisible messengers keep crossing a tiny abyss, enforcing a truce between things that should have torn apart from the beginning. And the same rules that grant that truce also decide when stars die. That may be the darkest comfort science has ever offered. The world is real, but it is not secure. If you felt that for a moment tonight, that strange mix of awe, gratitude, and unease, then stay with me. Subscribe, and we will keep following these quiet fractures in reality together. Because the deepest mysteries are rarely the loudest. Sometimes they are the smallest things in the universe, holding everything in place, one impossible nucleus at a time.